Happy Tuesday, guys. We've got another day of solving these systems by substitution. Today's problems are going to be the most challenging that they're going to get. And then starting tomorrow, you'll see another method of doing these algebraically that I think you're gonna really like. So let's take a look at what makes these a little bit harder. Notice this looks exactly like yesterday. The only difference is I starred step number 1. The reason I starred that is because yesterday I said just make sure that you've got one variable alone. Well, today, when you go to make sure that you've got one variable alone, you'll notice that we don't. So neither of these equations are solved for y or even solved for x. So that's something we're gonna have to take care of on our own. Everything else is exactly the same as yesterday. So we just have that one initial step that we're gonna have to put a little extra work into. So let's go ahead and do that. So for the example we have, making sure that at least one variable is alone in at least one equation. Let's take a look. We need to solve for one of these variables in one equation. Typically, the easiest thing to solve for is a variable that has a 1 as a coefficient and preferably a positive 1. So if you notice this one, it's a -1. That's not a bad thing, it's just not the easiest option. Whereas this x and this y, those are going to be easier to solve for. So we can choose either one. We can choose to solve for x or we can choose to solve for y. Doesn't make any difference. I'm going to switch it up because typically we've had y alone. So I'm going to choose to solve this equation for x. So what I need to do is move the y to the other side. This becomes x equals 4 minus y. So I'm just going to get rid of this for right now. And now we've just got these two equations. Now it's exactly like yesterday. We've got one equation that has a variable alone and the other equation does not. If x equals all of this stuff, all we're going to do is replace the x in the other equation with that stuff. So let's just rewrite the equation. 2 with what used to be an x minus y equals 8. In place of that x, I'm putting 4 minus y because that's what it's equal to. Now, step 3, solve for the variable that remains in the equation. So we're going to split it. We can distribute. We're going to multiply everything by 2. So this gives me 8 minus 2y minus y equals 8. Now we're going to combine like terms. -2y minus 1 more y is going to give me -3y. My variables are already on the left, so I'm going to move my constant to the right. I'm going to subtract 8. Final step, we're going to divide by -3 on both sides. So that tells me that y is equal to 0. So in my ordered pair, I know my y value is 0, but I still need to find that x value. So I'm going to take that and I'm going to plug it in. You can plug it into any of the equations, whether it's the two original ones or the one that you manipulated. It doesn't matter. I'm going to go into this one, the original one before we messed with it. So this means I would have x plus my y value of 0 equals 4. So this is just telling me that x is equal to 4, right? X plus 0 is x. So that's my x value. So remember, my solution is technically the location on the graph where these two lines are crossing. So we don't have to graph them by any means. We're actually done with this problem. But let's say you were just really curious and you wanted to make sure that you did this right. You could input these into Desmos and you can see what your graph would look like. You can input them just the way they are. You could type in 2x minus y equals 8. Or you could solve it for y. If I solved this particular one for y, I would subtract the 2x to the other side and then divide by -1. Here's what you would get. So this means we've got a y-intercept at -8 and we have a slope of +2. So here's my first line. Remember, you don't have to graph them this week. We're just looking to see if we got the right answer by checking it visually. Desmos will do the same thing for you. If I wanted to solve this one for y instead of typing it into Desmos, I would just have to subtract the x to the other side. So that means I have a line that has a y-intercept of 4 and a slope of -1. I found my intersection. I'm going to draw this in. And again, we're looking for where these two things are crossing each other. So here's where that crossing section is. And this is at x is 4 and y is 0. All right, so the only additional step today was that we had to look at those two equations and pick one of them to solve for one of its variables. And then it's just like yesterday. So on the back of this page, we've got 4 examples. I am going to do the first 2 with you, and then I'm going to leave you to do the other 2 by yourself. So let's get started. For this example, we are going to want to choose one of these equations to solve for one of its variables. It does not make a difference which one you pick. I think I'm going to take this equation, and I would like to solve it for the x value because its coefficient is a 1, so that's going to be really easy. So that means all I have to do is move this 2y to the other side. I don't have to divide by anything or change any signs. So that's what I'm going to do. I'm going to add this 2y over to the other side. It's going to become x equals 4 plus 2y. I don't really need this one anymore because I rewrote it. Now it's just like yesterday's. So now I'm going to say, well, I know x is equal to all this stuff, so I'm just going to replace the x. Let's rewrite this one. What used to be an x plus 2y equals 0. In place of the x, I'm putting 4 plus 2y. I'm going to solve for the remaining variable. So there's nothing to distribute, right? There's nothing outside the parentheses. So I'm just going to combine my like terms. I have 2y and 2y. All my variables are on the left. So I'm just going to solve. I'm going to move my constant to the right. I'm going to subtract this 4 to the other side. And we're going to divide by 4. I've got my y value, but I'm not done, right? We need to find the x value because we're looking for an ordered pair or location on the graph. You can plug that y into any of those equations, the first 2 or the one that you came up with. It doesn't matter. I'm going to go into the one that we came up with. So this tells me that x equals 4 plus 2 times our y value of -1. Careful with your operations, don't add the 4 and the 2 yet. This is really 4 minus 2. So I have that x is equal to 2. Remember, you can always plug these into Desmos to check them, or you can input 2 for x and -1 for y and make sure you get true statements for all of your equations. I'm going to move on to the next one. I think the equation that I'm going to solve for one of its variables is this one. The reason I chose this equation is because the y has a coefficient of +1, and that's just going to be the easiest thing to solve for. I could have solved for any of these variables. Like if I wanted to solve for x, I could add the y and divide by 2, but I didn't feel like it. I like this one the best. So when I rewrite this, I'm just going to subtract the 3x from both sides of the equation. I just think that looks a little bit nicer. So now what I'm going to do is say, well, if y equals all of this stuff, let's just replace the y with all of that stuff. So when I rewrite this equation, it's going to be 2x minus what used to be a y equals 6. And in place of y, we're just going to put that. Okay, we're just going to solve for the variable that's left. So I separated. We are going to distribute because we've got a negative sign here. That's really important that you don't lose it. So it's going to change the signs of everything in the parentheses. So I have 2x minus 9 plus 3x equals 6. I'm going to combine my like terms. 2x's plus 3x's is 5x's. All my variables are on the left, so I'm just going to put my constant on the right. I'm going to add 9 to both sides of the equal sign. And finally, I'm going to divide by 5. I have my x value, so I'm halfway there, but I'm not done. I need to take that and plug it back into one of these equations. It doesn't matter which one. Kind of like that one that we made on our own. I'm gonna use that. So this tells me that y equals 9 minus 3 times our x value. Don't do the 9 minus 3 yet, make sure you multiply first. This says that y is 0. You can check it on Desmos, or you can input x equals 3 and y equals 0 into our equations and make sure that you get a true statement. All right, we're at that point. We did 2 together. So now is where you guys should push pause and give the last 2 a try on your own and come back when you're ready for the answers.